In this problem, we have to reverse the words of a string, and within the word the characters will remain the same. So here this is one word, world, followed by this is exclamation. So this remains as it is. So the last word will become first word, second last word will become second word, and similarly first word will become last word. And there are some more conditions that input may have some extra spaces in the beginning, one or more spaces, and even between the words it may have one or more spaces. At least there will be one space between different words. So space is the only delimiter here. So in the result we should not have either leading zeros or trailing zeros. We should get rid of all of those, and even in between words, if we have, let's say, 3 space here, in the result we should have only 1 spaces. So if there are 10 words, there should be 9 spaces between those, one between each pair. So let's see how we can solve it. So the idea is to try to find the words. So we start with 2 indices. We keep track of the beginning and end of word. So we start traversing from the left in this string. Let's call it S. And we keep a index I equal to 0. 0 is the first index in a given string. So we start I from 0, that is first character. This may be a space, this may be a non-space character as well. So we keep incrementing I. So while I should be less than s dot length, let's call it n. So while I is less than n and s of I is equal to space. So I denotes the beginning of word, and we will keep another index j that will denote where the word ended. So this will denote ending or one more than ending. So this way we will start from the beginning. So no matter how many spaces are there, we will keep incrementing this I. So in this condition we have to do nothing but keep incrementing I until we find a non-space. So if both conditions are satisfied, we will keep incrementing. Here it's a space, we will move I here. Here also there is a space, so we will move I here. Now it's not a space, so it will come out of this loop. So I will remain here at the H letter. Then we will have another variable j equal to I plus 1. So we will start j immediately next of it. So j is initialized here. And here what we will do, while j is less than n. So n minus 1 is the last index if the length is n. So that's why n is not a valid index. So we stop as soon as we reach n. And s of j is not equal to space. So j is less than n and this is not a space. So keep incrementing the j. So I was looking for non-space and j is looking for a space, first space that it encounters. So again not a space. So move j here. Again it's L. Move j. Move j. Now as soon as it goes just after O here, there is a space. So this loop will end. So now I is pointing to this, j is pointing to this position. So we can find this substring. So get the substring out of that. S dot substr. So whatever is the syntax of substring in the different languages. In C++, it's first one is the beginning index, which is I. Second is the length of substring. So it will be here j minus I. In Java, it's first index and 1 past the last index. So in Java, it will be exactly s dot substring I to j. So this is Java. This is C++. And in Python, it will be similar. We will have a splice s I to j. So this is in Python. So this way you find this substring and this will denote a word. Let's call it W. So we will not include a space. Space is not included in this, only the word. And we will keep a result. So initially result is empty. So there are 2 conditions. Either this is the first word in the result or we have already some words. So if it's first word, simply make result equal to W. So this W is hello. So it will be hello. And no spaces. Next, after this loop, this is W, we put result equal to, we put it in the beginning so that next word again comes in the beginning. So let's call it W. So W plus space plus result. But you have to add a condition here that if result is empty, then don't add this part. If result is not empty, then add this word, add a space, and whatever was the earlier result. So this is conditional. So after this, where should we move I? So we have taken this word and J was pointing to a space. So no point in checking for J itself. You can keep I here also, but let's move I one more than J. I equal to J plus 1. And again this loop will continue till outer loop is I less than N. So while this is true, keep repeating this. So now I is here, it's a space and it's less than N. So increment I, maybe there is one more space, again increment, and when it reaches here, I stops here and J will be, where is J? J is one more than I. So J will start from here until it finds a space, it will keep moving next. When it reaches here, it stops. So again we take the substring, this time it will be world. So this time the result is not empty, so we will add this part also. So result equal to, W will be this world exclamation, then this space, then earlier result which is hello. So J is here, I will come here, and while I less than N and it's a space, increment I. So I will increment here, and now I becomes exactly equal to N, so we stop and we return this value. So this is how we can solve this problem. There is a follow-up problem here that for C++ users, try to not use any extra space, use O1 space. So we can modify it slightly, the logic will be modified. Since we are inserting in the beginning, instead of result, we will modify in the input string itself. So what we will do, let's say J is here, this is the input string. So we will delete everything and we will insert the W in the beginning, and then keep track of till what index, what was the earlier older J index. So it was here, and what is the I now, next I. So I will be this one. So you can find out how many spaces were there. So you will trim those many spaces and recalculate this N. So whatever N we had saved, so there will be a new N due to deleting of some space. This N will, it may or may not decrease. So if it decreases by 2, then what we have to do, we have to decrease 2 from this I also, since we deleted 2 spaces. So this W will shift left, and then you should shift this I also here, or you may keep it at older J. So this is how you can modify it and keep updating in the string itself. So now let's write the code for this. So you are welcome to try this approach using the idea that I just said. You may have some different idea. So this is the empty result, I equal to 0, and let's keep the length since we will be using it quite a few times, so we can store it. While I less than N, If result is empty, then this is the first word, so result is equal to sub. This sub is the word that we saw in the explanation, substring. Else, if there are already some words in the result, then result equal to this new word in the beginning plus one space plus older result, and then I equal to j plus 1, and this again will continue for the next word until it reaches to the end. And the solution is accepted. So what is the time complexity here? We are doing one scan of this word and nothing more than that. We are also picking substring from here to here. So this will be O of word length. Again we will scan from here to here, again O of word length. So total it will be O of number of characters in the original string. And space, we are using a result as extra variable, so you can think of it as order n space. But we can modify this logic slightly with the idea that we just discussed to update this input string itself and result that updated string. Now we will write this in Java and Python. And the Java solution is also accepted. Finally, we will do it in Python 3. So we can do all of this in one line. And the Python solution is also accepted.